Ladies and gentlemen, welcome to our expert talk on Formnext TV. In this edition, we will talk about metallic additive manufacturing, and I have three guests with me here in the Formnext TV studio. To start with, it's Kartik Rao of Oerlikon AM, welcome. Dr. Markus Heering of VDMA, welcome here at the studio, and as my co-host, so to say, Sascha Wenzler, Vice President of Formnext, welcome. We will talk about metallic additive manufacturing, and the market is growing over years already, and the future looks great, and we will talk about the present and the future in our little show today. So Markus, you did a survey recently amongst your members of the VDMA organization. What is the actual status of additive manufacturing metallic?
Yeah, we're doing a survey twice per year in spring and in autumn. To check within the additive manufacturing group, around about 160 members producing AM technology and also using AM technology, about the market situation, how they see the market. And this time we also asked them about the materials, what materials they use. And the answer was interesting because 90% are using metal. That means half, only metal. And also half metal and plastic materials. So in total, 90% using metal as a basis for AM technologies.
Did that change recently? Was the survey differently when you did it, let's say, 3 years ago?
This was the first time that we asked about the materials. Before we just asked about the market situation. Therefore, we have now a comparison. We did, I guess, 2 years ago, a study about or a survey within total VDMA membership about the IM use, and there we found out that round about 60% are using both materials, metal and plastics, and round about 30% just metal. So it's a little bit comparable as we had 2 years ago.
Great. Sascha, the funny thing about the additive manufacturing community is that actually there is an interaction between the two groups, the metal group and the polymer group. I don't know any other industry where you have such a combination, a cooperation between those extremely different groups. But in additive manufacturing, it exists. How do you judge this, and what are the advantages for future developments?
Yeah, it has a little bit to do with the very young history of additive manufacturing finally, because it's round about, let's say, 30 years in use, and it's even a shorter time in use when we take a look back in real industrial use for a shorter period of time. And still up until today, the companies emerging back then and joining now the community are very deeply connected with each other. And what we also experience at the show floor is at Formnext that there is a lot of communication going on between the companies too. So that's very important because it still gives a big push to the technology, and it's a driver of the technology because it lives off the exchange, and it lives off the exchange of experience. And therefore this vivid community is a good example, and I agree totally, Guido, when you look at other industries having a much longer history, there was a certain time when maybe there was a kind of separation, and maybe the competition grew too much towards the cooperation and towards the dialogue. But for additive manufacturing, it's still a very intense communication.
Talking about companies with a long tradition, Oerlikon is one of the best examples because this company has a very long tradition. Kartik, how did additive manufacturing change the philosophy of producing for company Oerlikon?
So we've been in additive manufacturing now for well over 5 years, and so we're not an early player by any means. But our entry into the additive manufacturing space came via the metal powders. So we're a metal powder manufacturer. That's how we initially got started, but then we very quickly realized that actually what we wanted to do was to add value to those metal powders. So not just sell the powders, but also print parts for our customers. So we do have a traditional machining business where we do manufacture parts for aviation engines and land-based gas turbines today. And we could see a competitive threat in the future for that business coming from additive manufacturing. So this is also one of the reasons why we got into this space. It became very interesting for us that actually, this technology is no longer just a curiosity in an academic environment. It very much has industrial potential. And we've seen that in the last 5 years. So we've seen the market grow and grow. We've seen the interest from OEMs and their tiered supply chain grow and grow. And we absolutely think that it's the right space for us because we're able to use our pedigree of metallurgy, our metal powder experience, and also the knowledge of the process because it's not just a matter of buying a machine. There's a huge amount of intellectual property that goes into actually manufacturing a part, a functional part at the end. So I'm interested to hear actually that your members are saying they're definitely getting more into the metal space. It confirms what we see in the market, both in the US and in Europe. So it's important to say actually that both markets are vibrant.
Yeah, and of course, the plastic sector is a little bit easier to handle than the metallic side. The process itself may be a little bit easier, but especially if you're speaking about metals, you have a process chain. That means you have a post-treatment. You need a post-treatment to use the material, the products afterwards. That's much more easier to handle with plastics, and therefore I guess this is the reason that now metals, with the experience what the first manufacturers have, it's coming more and more to the market, and it's more and more relevant to the market.
Well, when we spoke about the products being produced either metallic or polymer last year, we could hear that the market or the community is changing quite a bit. Whilst in the beginning they were mainly producing prototypes in small numbers, now we are entering a phase of serious production. How eminent, how important is that to the community, and how do you see the actual need for serious parts being manufactured in an additive way?
First of all, I see prototyping was the history. It's still an important issue, but I guess the future is serial production or industrial use. I guess this is better than serial production because industrial use implicates much more. That means we have to compete with also traditional procedures. And I see the future is not to use additive manufacturing instead of the traditional production technologies. It's more an add-on. You need an added value. You said it a little bit before. Additional functions you can implement in AM products. And if you do it from beginning on with the engineering and have in mind that you will produce later on AM basis, you can bring much more things in the product, bionical functions. You can implement some other cooling lines, whatever you need. And if you do that, you get an added value at the end, and this brings much more benefit than using AM instead of traditional ways. It doesn't matter if it's foundry technology or what else. And this is so important to know and to have in mind. That this is a different way of thinking and bringing it in. When we started AM working group within VDMA now 6 years ago, after a short time, one of the main targets was bringing this technology into an industrial use. And we are still on the way to close the process chain, use digitalization as a basis for the individual steps. We have a roadmap created on that. And I guess this is important for the future, that you have a technology what you can implement in industrial procedures. We have some steps to go, but we are in a good way. We have done a lot of steps. And you had it before from Oerlikon. We have many other examples that we see. If the companies are doing in that way, we're going forward, and it started with an industrial procedure.
To me, it seems as if there are two worlds growing together. The one is the typical startup world of young people with their garage-based little companies on the one side, with fresh new ideas, with visionary thinking. And on the other side, there is an industry, a grown-up industry, which has learned to earn money over ages. And now these two things go together. On the one side, I think that it is helpful for the youngsters to learn from the grown-up companies, but doesn't those companies slow down the youngsters also when introducing the industrial approach? What do you think, Kartik?
I think they complement each other, and you know what we see is a natural progression of the technology in the industry. And you know, I always talk about this in terms of the product life cycle. So people look at a standard product life cycle as beginning with prototyping, going into pre-series, then into maturity, then into the aftermarket, when you slowly decline the product out of the market. And traditionally, additive manufacturing, you know, these young guys have been focused on prototyping. You have these small service bureaus, fast shops, who are able to react very quickly to the OEMs. So they do it much better than an internal OEM rapid prototyping network, right? So they're able to survive there. So they're definitely a very useful part of the market for, you know, the large OEMs that you see in Germany. And where I think the larger companies play a part is in helping companies make the transition from prototyping into pre-series and into the maturity phase. Because as the costs of additive manufacturing and the knowledge about additive manufacturing, specifically about metals, grows and the costs come down, we see the technology being used more and more into this in this maturity phase. Mm-hmm. So here is where you need large companies who are willing to invest their capital equipment, invest in people to be able to guarantee a part production run of 5 to 10 years. And this is where the larger companies, the more industrialized players, can offer that guarantee to an OEM. So it's very much a partnership, really, and we very much see it as a complementary ecosystem where we can work with these smaller companies, and where the OEM has a requirement for obviously larger scale production, and they're looking for someone with the financial firepower to get in there, and the metallurgical firepower, intellectual firepower, everything else. Then you get the larger players coming in. So in Germany in particular, you see this industry being very vibrant and a good mix of large and small companies. It's essential.
And last year on Formnext in Frankfurt, we had several interviews with some of your exhibitors, Sascha. And the funny thing was that the traditional companies, all of them mentioned that it was so nice to them how vivid, how vibrant this branch, this industry, this community is. And for them, it was something completely new. On other trade shows, you have this, grown-up, stiff style, right? And there you have this blue jeans t-shirt style, which of course is not the whole story, but it contributes to this feeling with this technology. Will the community be able to preserve that, to keep it in the future, or do you think this will be lost every year that the technology is becoming more normal?
We're working on this to preserve this special feeling and to preserve this special community. But yeah, it will depend on also the velocity of the growth of the market, the velocity and the development and the increase of players coming in. And then, yeah, there might be a certain point in the future when the market is so big and the number of players is so large that maybe a little bit of the community feeling disappears. But we are strongly working on this, and it's exactly like you said, Kartik and Markus. It's all about partnership, and our job as a show organizer is to enable these partnerships. And therefore, when you enter the halls, Guido, you experienced it and you described it perfectly. It's really a very, very vivid atmosphere. You go in and you feel a certain kind of energy. And I think that's really a driver coming out of the community when you have a block of young startup companies with fresh ideas and sometimes crazy minds, but joining the very serious and big industrial giants or companies or corporates, and but both together they act and they create something. And yeah, you see it in the market as well. There are some buy-ins, buy-outs, cooperations going on, joint ventures emerging out of the community and out of this branch. But everything happening brings AM one step further. And I think that's all what's driving us.
As I said in the beginning of our little show, it is completely new to the industry that companies consider working with different materials. So it would have been impossible in the past that, for example, a steel mill would go into the plastics industry and offer plastics products. Very few examples in the market exist. Usually they stick to their own materials that they have been working for ages. In the AM industry, this is different. Could it be that maybe Oerlikon in the future also works with polymers?
We already do. So we have some plastic experience. It's not as extensive as a metal one, but we definitely have some exposure to that market. It's a very different industry, and although they work together, and you can see that some customers definitely have they have an interest in both polymer and metal parts. We've ended up focusing more on the metal side because I think it would be fair to say that where the real challenges are today is on the metal side, where the industry still hasn't really shaken up or joined up the value chain in quite the same way that the plastic or the polymer industry has. Here I think we'll continue to see more industrial emphasis on the metal side of 3D printing. It's not to say that the polymer side won't continue growing. I mean, you still get much higher growth rates than you do in traditional background industries. But definitely what we see is the higher growth rates are on the metal side.
Do your members share this opinion?
I don't know in detail, but I think he's right. I see a little bit more potential in the metal sides. There are more perspectives, what you can develop, what you can do. Also, speeding up is a question there. Capacity of the machines, costs is a bigger issue. So the potential for growth, I guess, it's a little bit bigger in the metal side than in the plastic side. But also for the polymer side, I see a future in the growing market. But yeah, as I said before, for the metallic side, I see some potential more.
Mm-hmm. I mean, I think with the plastic side, what could be interesting is certainly the educational side of the market. What we keep forgetting is that you need a generation of engineers who learn or grow up in the additive space. And here, I can definitely see that actually there's going to be an acceleration of polymer printing in universities and schools and so on to be able to train this next generation of engineers. That'll become the sort of nursery ground of metal additive in the future potentially as well. Yeah.
Kartik, perfect point. Because when we look at the customers coming to see Formnext and to see the variety of machines, products, processes over the last years, and from the very first beginning in the first or second year, we learned, hey, there is a big amount and a growing amount of people coming in from smaller or medium-sized companies who need education what to ask to the exhibitors on the show floor. Because for them, it's maybe in the mind, hey, I've heard about 3D printing, that's a nice new technology. Maybe there is something in for me, let's check, let's see. And there was a gap between, and still is a gap between knowledge in the application, in the usage of AM technology, and you're totally right, looking at the whole process, especially in metal AM, there is a gap in the knowledge. And so our job is also not only to show machines, but to encourage the exhibitors to show solutions. And we support it, for example, to create a kind of know-how transfer. When we offer specialized seminars, we call them Discover 3D Printing, just to directly have an orientation for the smaller and medium-sized companies and their owners and their technicians, to school them a bit before they enter the show floor. And then they are a little bit prepared to ask the right questions to the exhibitors to come into a more efficient or effective dialogue with some results, which is much, much better than just coming in, showing a part, and that's what you all know, showing a part and saying, hey, can I print this? Because then regularly the answer is yes, I can do it, but it's a totally different cost, and finally it's the wrong approach. So this know-how transfer, I think, is necessary, still necessary in a huge amount.
Talking about transfer, I would like to talk with you about a topic which is the transition of the companies due to the fact that AM manufactured parts require a totally different approach from the R&D side. So there is a saying that those best products in the market with additive manufacturing do have the best design for additive manufacturing. So you cannot just copy a traditional product and print it. It doesn't make sense. But if you really use the advantages, the freedom of designing and developing, then you have a brilliant product. But this has an impact on the structure, on the organization in the companies. How did your company do it? And how could you implement this new way of thinking in the R&D area? And how are you experiencing that today?
I guess everyone will take a slightly different approach. I mean, because we came in fresh, we had to go to market basically to bring in an entirely new R&D team, purely focused on AM. We didn't have the expertise internally to be able to bring it all in. We had the metallurgists, so we had the coating experts, but we didn't have the people with the printing know-how or the machine know-how. So we went out and acquired that. We bought a company, we hired an R&D team, so that was a choice we made. I mean, we see different approaches in the market, so some of the customers that we speak to who struggle with this challenge of how do I take my existing parts and make it AM, make it by AM for the future generation of aircraft, aero engines, trains, whatever it might be. Here, they're seeking training support and help. It goes back to the point we made before. They're actually going to market to say, okay, come in and teach our engineers. What is the potential of additive? How would it compete against casting or machining? Because this kind of knowledge is missing. So people often see the design advantages of additive manufacturing, but they don't quite know how it stacks up on an industrial basis versus machining and casting. And this is the educational leap that we have to help the customers with. So we're definitely in sort of business development mode. We're having to create our own market by helping these customers make that transition from traditional manufacturing to additive. Different companies will approach it differently. We see some companies in the US again, taking the same approach of growing by acquisition. So they've bought smaller companies, those startups that you started talking about. So these smaller service bureaus, they just acquire them and they bring that knowledge in-house. And that's because of reasons of protecting intellectual property, or maybe they want to make it themselves rather than buy on the market. So we see a spectrum of approaches.
Do you think that competition is better than freedom of development? Do you think that there should be a fight among the traditional manufacturing or R&D processes and the new one? Or do you think it is better to have some kind of think tank outside the company to enable the designers to create something completely new? What's your opinion?
Depends on the company size. What is the right solution? I guess in the future, you have both technologies, and they will also in 10, 20, 30, 50 years, you will use the traditional technologies for production and the AM technology. It's just another way to do. What you need to do this is you need, as you said before, education, educated people. It's difficult also if you're now getting engineers from universities. They have known a little bit, have heard a little bit about AM maybe. You can't be sure. This is a challenge. It must be implemented. We raised that also at the ministry in Germany. It have to be implemented in educational plans. That must be a must, and it must be comparable over Germany. It's not the solution. Now we have the situation. Each university created their own idea of implementing AM technology into the plans, but it must be in every curriculum in the same way described that you have an engineer, machinery building, machinery engineering, and you can use them also for AM. It's a different mindset, and I guess it's difficult to have an old engineer, 60 years old, who now worked 40 years with traditional technologies, and he knows that very well, and now say you have to switch to AM. It's a challenge. It could be a possibility that it works, but it's I think it won't do so. And what I see, if I look to VDMA members or to mechanical engineering in Germany at all, what we see is a lot, sometimes 60 to 80%, depends a little bit from the sector, still using AM in different ways. Some of them have young engineers, they have done that at home. They started with plastics at home. This is a typical B2C product, and they made the first experience, and then they have it. The company was able to install an AM machine there, and they use it, and they have ideas, they create ideas, and they bring it now into the process line. It takes time to do that, step by step, so that also can work. You don't have to go outside to a think tank and say, create a new product for me. And also, if you do that, the company must be open for that. If you still have the engineers in the decision positions and they say, we do it the traditional way, it's calculated on each cent, there is no way to bring it in. So this is a challenge. But we also have to say it's not the only challenge what we have in the industry. We're speaking about digitalization. At all, for every technology. And what means that on the products, in selling, in sales, digitalization and everything. So this is another challenge. And I guess AM is a good example for an add-on also in digitalization. Because this is a digital procedure and offers you more flexibility, different way to handle things and be creative. And as we had before, the situation with the young talents and the startups and the traditional companies, I guess we need the mixture. In the landscape of AM, we need the mixture between startups and the guys what has the experience. And also within the company, we need the mixture of young people with innovative ideas, with new ideas, absolutely. And also they must have the opportunity to ask every question. Make that sense, what you have done within the last 50 years. And if you're so open to do that, you also can implement AM in your business. But that is what you need. You must be open for everything. You must be open for the young ideas, for the new ideas. But we need also the traditional ones, the OEMs, the big companies, to deliver service, to deliver products, and to have the money in the background. If you would have just young talents and startups, I would not sure that this is the right technology to bring it to market. But now we have the mixture, and that is what you need.
Very exciting. Gentlemen, thank you very much. It was a pleasure discussing with you about this vibrant technology of metallic additive manufacturing. We will carry on discussing in the future, of course, because there are plenty of topics which have to be discussed. Thank you again for watching or for participating, and thank you for watching, and see you in our next edition of Expert Talk on Formnext TV.